Let's go to 11a. Show that sine 105 degree plus cosine 105 degree equals 1 over square root of 2. We know 105 degree equals 60 degree plus 45 degree. Let's use this formula. SC plus CS. Sin 60 times cosine 45 degree plus cosine 60 degree times sine 45 degree. 60 degree, let's label square root of 3 over 2, 1/2. Square root of 3 over 2. Cosine 45 degree, square root 2 over 2, square root 2 over 2, times square root 2 over 2 plus 1/2 times square root 2 over 2. Square root of 6 plus square root 2 over 4. We will use the same way to figure out cosine 105 degree. CCSS subtraction 1 over 2 times square root 2 over 2 minus square root 3 over 2 times square root 2 over 2. So we get denominator is 4, numerator square root 2 minus square root 6. So sine 105 degree plus cosine 105 degree equals, denominator is 4, square root 6 plus square root 2. Plus square root 2 minus square root 6. Combine like terms, we got 2 square root 2 over 4 is square root 2 over 2 equals 1 over square root 2. Let's go to 11b. Show that cotangent alpha equals tangent pi over 2 minus alpha for alpha greater than 0 less than pi over 2. Tangent pi over 2 minus alpha. You will get tangent pi over 2 minus tangent alpha over 1 plus tangent pi over 2 times tangent alpha. We know tangent pi over 2 is undefined. In other words, we cannot use this formula to prove this identity. So we have to change tangent into sine pi over 2 minus alpha over cosine pi over 2 minus alpha to prove. We still use these two formulas. Go to quadrantal angles. This is pi over 2, CST. Cosine pi over 2 is 0. Sine pi over 2 is 1. Tangent pi over 2 is undefined. For sine, SC minus CS. Sine pi over 2 cosine alpha minus cosine pi over 2 sine alpha over CC plus SS cosine pi over 2 cosine alpha plus sine pi over 2 sine alpha. Cosine pi over 2 is 0. This is 0, so this is gone. This is 0, so this is gone. Sine pi over 2 is 1. So we get cosine alpha over sine alpha equals cotangent alpha. Right hand side equals cotangent alpha is left hand side. So we finish this proving. Let's go to 11c. Show that sine of theta plus pi over 2 equals cosine theta. Left hand side equals, we got to use SC plus CS. Sine theta cosine pi over 2 plus cosine theta sine pi over 2. 0, 1 undefined, pi over 2, CST. Plug in the value. Sine theta times 0 plus cosine theta times 1. So we get cosine theta equals right hand side. Let's go to 12. The functions f and g are defined by this. The curves y equals f of x and y equals g of x intersect at a point P, whose x coordinate is k, k greater than 0, less than pi over 2. Intersect at point P, and x coordinate of P is k. So we can set up cosine k equals tangent k. Cosine k equals, change tangent into sine over cosine. Then times cosine k both sides. Reduce. We got cosine square k equals sine k. Let's go to B. Find the value of sine k. Give your answer in the form a plus square root of b over c, where a, c are integers. B is a positive integers. We know cosine square k equals sine k. We also know sine square theta plus cosine square theta equals 1. So cosine square theta equals 1 minus sine square theta. In other words, cosine square k equals 1 minus sine square k. We are looking for sine k. So we know this is a quadratic equation. First step, we need to get equal to 0 form. Move everything from left side to the right side. Because the coefficient of sine square k is negative on the left side. Remember, cross the river, change sign. Sine square k plus sine k minus 1. We will use this formula because we cannot factor this. Let m equals sine k. So we get m squared plus m minus 1 equals 0. coefficient of m squared is 1. B equals 1. C equals -1. So we get m equals -b is -1 plus or minus the square root 1 squared minus 4 times 1 times -1 over 2 times 1. Simplify. We got -1 plus or minus the square root 5 over 2. So we get m1 equals -1 minus the square root 5 over 2. Or m2 equals -1 plus square root 5 over 2. We can write down sin k equals -1 minus the square root 5 over 2. Or sin k equals -1 plus square root 5 over 2. We do know sin k is greater than or equal to -1, less than or equal to 1. Since -1 minus square root 5 over 2 is less than -1. So we cross this out. -1 plus the square root of 5 over 2 is in this range. So this will be the final answer. Also from B, find the value. They didn't say values. They said find the value of sin k. Means only one solution.